Okay, so I accidentally forgot to record and then had some problems when I tried to do record for the live class. So I'm going to walk through this one more time for you guys, and hopefully you will be okay. Well, this unit that we're going to be starting here is all about conic sections. And conic sections are about literally if I were to have a cone, and actually two cones nose to nose here at the vertex, what would happen to that if I were to slice through it with a plane? And we look and we see, okay, that slice is going to have a kind of a cutout, and that cutout is referred to as the conic sections. And those conic sections are all going to come from this here. This is standard form. Standard form talks about putting your squares first, then your non-squares, working your way down, powers, and always alphabetically. And the main ones that we're going to be talking about in this class, actually all of them, are circles, which happen when we are cutting what's called perpendicular, so that if I were to draw a line here, perpendicular to the axis, you have a circle. When you have some other kind of angle, it's not a right angle, but it's not too steep, and you're only going to cut through one cone, that's going to create an ellipse. If you look at this line here that makes up the edge of the cone, if we were to do a plane that is parallel to that, in other words, non-intersecting, non-touching, that's where we come up with the parabola from. And if it's not parallel, if it's anything else and it slices through both of them, that creates what's called a hyperbola. But we're going to go through all of those step by step a little bit later. Today what we're focusing on is this idea of completing the square. Completing the square says I am looking to get something to be written in the form of a plus b squared. That's a perfect square. That's what I'm going for. If I were to FOIL this out, that's a plus b times a plus b, I end up getting a squared plus ab plus ab plus b squared. So a perfect square trinomial is something in the form of a squared plus 2ab plus b squared. And so what we're looking at here is we have something where if I take the square root of that, use it, I take the square root of this end and use it, and I multiply it by 2. That number is always going to be 2. If I can do 2 times the square root of the first and the square root of the back, then I can have a perfect square trinomial. So what we're going to do here, you need to understand there is no equal to symbol in this problem. Okay, I'm not solving anything. I'm just trying to follow this pattern to say, what am I missing to be able to write this in a perfect square form? So the way that we do that is we start, I usually go like this. I want to be able to say something here and something here squared and have it equal to what that would be. So the way that I do it is I take the square root. Then I look at the middle term. You see how this x is already there? So I'm going to kind of ignore that x. I'm going to look at the 6. And since what I have here, I need to have that 2, I'm going to take that 6, I'm going to divide it by 2. And a positive 6 divided by 2 is a positive 3. But I need to figure out what's going to complete this square, because that's what I'm looking for, and that's going to be 3 squared, which is 9. So what this is saying is if I were to FOIL this out, I should start with an x squared, a 6x, and then hopefully that 9 is what I'm missing there at the end. So first, outer, inner, last. So those guys do give me the 6x. So that's what I was looking for. Number 2 is really the same thing, but we're kicking it up a notch. We're tacking on a negative. What happens if I have a negative out in front? Well, what I like to do if I have a negative out in front, I kind of just get rid of it to start with. I'm going to say that this is negative x squared minus 5x. So I pulled out that negative. And now I want to figure out what goes here. Again, I'm going to take square root Ignore that piece of the middle term and divide by 2. So that's -5/2. Then I'm going to square that number. Negative squared is always a positive. This number here is always going to be plus. 5 squared is 25. 2 squared is 4. But I want to know what number I would put into it without any parentheses. So what I need to do here is I need to remember, and this is the biggest mistake folks make, I need to remember that there's a negative that I'm distributing to everything on the inside, and that includes the very last number. So that means what goes in out here is -25/4. That's the number that completes the square. And when you're writing your final answer for this, just make sure that whatever that negative that you pull out, because our goal is going to be writing it in this form. Don't forget that negative is out there in front. So these two here are now equivalent. So if I'm looking at problem number 3, 3 is nice. 3 doesn't have a number out in front, so I'm okay with that. But what 3 does have is a not so nice number in this place. So what happens if, for example, that number is not nice? Well, hey, we just did one. That one had a fraction in it. Don't let fractions scare you. All I'm going to do, there's no number out in front, so I'm going to take the square root. Ignore that from the middle piece. Cut that in half, so -7/2. And square. But to make these two equal, I have to figure out what did I just put in. I just put in -7/2 squared. A negative squared is positive, so it's always a positive. 7 squared, 2 squared. So that's the number that we're missing. For problem number 4, well, we are back with something out in front, but what's out in front this time is not just a negative, it's a 2. But I follow the same steps that I did above. I'm going to just take that 2 out and kind of ignore it. So I'm going to have 2 times x squared plus 4x, and I want to figure out what number I'm going to put here. So let's work through completing the square. Square root, ignore the x, take half of that. Square that number. 2 squared is 4. But I didn't just put in a 4 there. There was a 2 out in front. So 2 times 4 is 8. And so the number that completes this perfect square, if I can get that guy, there we go, is 8. And I can always check these by foiling them back out. So this would be 2 times x squared plus 2x plus 2x plus 4. So that is 4x. And 2 will give me 2x squared plus 8x plus 8, which is what we wanted. You don't have to do that stuff. I'm just trying to illustrate for you here that that is the same thing. Now the whole goal of this, we are not really trying to learn new things here. The whole goal of this is to put things into what's called vertex form. Vertex form, we've seen this before with parabolas, is when we have y equals a times x minus h squared plus k. So basically what we're doing here is we're going to take the opposite of what's next to the x, and when it's written in this form, the same as what's next to the outside, and so my vertex is at h comma k. Or we can write it this way, and actually this guy here, he is the way that we're going to be doing most of them. And that is actually kind of nicer because we get to say the vertex here is going to be opposite of what's next to the x, opposite of what's next to the y. So it'll keep things a little bit simpler. We're going to come back and play with the actual vertex forms when we do each of the individual conic sections. But I'm not going to be worried too much about that right now. I'm just going to kind of work this through. All right, so this is my goal. My goal is going to be to get something from this standard form here, where it's written with squares and x's and y's, and I want to get it down into something like this where I have perfect squares, because that way I can just look at it and pull the vertex. So we're going to put each of these guys in vertex form. These problems are a little different than what we did before because I have an equal symbol. Remember what we did up here? There were no equal symbols. I was just kind of playing with this. Now we've got to try to make sure that we keep my equation balanced at all times. So we're going to take this the same way that we would have done, and we're just going to look at the first two terms here. And I'm going to use completing the square on those first two terms. So I'm going to say that this is equal to, I'm going to work on this stuff in here. So we have x squared plus 10x, and then we're going to look for that something that goes there. So when I complete the square, I take, just like we've been doing, square root, half of that, and then square it. So what I'm doing is I just put 25 in. But when I'm dealing with an equation, I have to be careful, and I have to make sure that I balance it out. This is no longer equal. What I've done is I put 25 in, so I'm going to have to take the 25 back out again. And that will leave me with y being equal to x plus 5 squared minus 35. And just to show you, the goal here was to get this to be the vertex form of this equation. So if I work that out, that's going to be x squared plus 5x plus 5x plus 25, so that's what's in the parentheses, minus 35, which sure enough is x squared plus 10x minus 10, which is what we started with. But this down here, this is just checking it. So don't freak out. I'm not going to ask you to check it all the time, but checking it is very beneficial. All right, let's try a little bit trickier of a problem. This problem is tricky, and ladies and gentlemen, I'm giving you here some of the hardest problems. We're going to do just 10 of these. When we get to problem number 10, it's going to be ugly. But if you can handle the ugly problems, you're going to be able to handle the easier ones. Again, the way we start this, I'm going to do completing the square on those first two terms, always on those first two terms. And I've got that plus 7 just dangling off the end. Now before, when we completed the square, we had a multiplier out in front. We pulled that multiplier out. So I have negative 3 times x squared. When I pull that negative 3 out, that's going to become, careful with your signs here, 6x. Now I get to just kind of fumble my way through it. So I want to color it, pretty color, purple. That means completing the square. Square root. Ignore the x because it's already there. Half of the 6 is 3. Square that. 3 squared is 9. But I didn't just put in 9, I put in 9 times negative 3. 9 times negative 3 is negative 27, so I've just put in negative 27 to my equation. So to balance it out, I'm going to add a 27. I'm going to do the opposite. So that's going to become 34. And there's my vertex form. And again, what we're going to be going to eventually is just to be able to look at this and say, okay, now my vertex is going to be at negative 3, 34. So there's a reason why we're doing all this. We just haven't really gotten to the place where we can apply this stuff yet. It's always half to go from here to here. It's always opposite what you put into the equation. You have to balance that out. Okay, this one's a little bit trickier because not only do I have a number out in front, I also have a negative. So we've got a couple of things to deal with. When we do completing the square, we're only going to talk about these two. So I'm going to leave that plus 20 hanging off the end. When I complete the square with this number in front, I factor that number out of those two terms, which will leave me to x squared. When I take out a negative 2, 12 divided by negative 2 is negative 6. If I were to distribute this, I'd be right back to the beginning. I'm good. I haven't changed the values. Now we complete the square. Square root. Half that number, keeping that sign, Square it. Negative 3 squared is 9. But I didn't just put in the 9, I put in the 9 times the negative 2. 9 times negative 2 is negative 18. So at the end, I'm going to put in a positive 18. So there is my vertex form. Number 8, and if you look here, look, we don't have too many to do. We're doing okay. Number 8, and even the last ones that we're going to deal with, these guys get hard if you can't figure it out. They get difficult because look at this. Fractions. This one's got fractions all over the place. We just need to make sure that we understand how fraction rules apply to this. I'm going to take all of the same steps. I am going to only deal with these first two terms. Just so happens here, the number out in front that I need to pull out is 1/3. I'm not doing anything to that 16 over 3. To factor out 1/3 is the same thing as to times by the reciprocal. So if I were to do negative 2/3 times the reciprocal, I just get negative 2. So that's the number that goes here. Or you can think, because they all have a common denominator, I'm just going to worry about the numerator. Either way, I don't care. It's all right. But this is the problem that we're at right now, this guy here. So we just complete the square. So we're going to say y equals square root half, square that last piece, negative 1 squared is positive 1, and balance it out because I've got positive 1 times 1/3. So that means I've put in a positive 1/3, so I'm going to take out 1/3. 16/3 minus 1/3 is going to be 15/3. And 15/3, hopefully that's not a big leap for you, is just 5. So completing the square gives me 1/3 x minus 1 squared plus 5. And that's your final answer. So in reality, it's not as bad as what we started off with. And if you ever kind of doubt your work, you're more than welcome to just go back through, FOIL this out, and see, do I end up with what I started with? But in vertex form, this is what we're asking you to get to. So we're going to do 2 more of these. And ladies and gentlemen, I really hope that you're pausing this as you're going through and trying to see if you can do them on your own. So before you see how this one's worked out, I'd recommend just hit pause right now, try to work this one out on your own. I'm going to start going. Again, I'm going to complete the square on just those first 2 terms. Oops. So I will have y equals, but I need to pull out that multiplier. Now it's your choice. At this point in time, you can get a common denominator here. I kind of like to think just like on the side. I like to kind of think I've got negative 15. To divide by this negative 3/4 means to multiply by the reciprocal. And when I do that, negative times a negative is a positive. 3 goes into 15 5 times. 5 times 4 is 20. So that means the number that goes here is a positive 20. And again, if I were to multiply, negative 3 times 20 is negative 60, divided by 4 is negative 15, so it all works out. And so that's actually the last of my fractions, or mostly, that I need to deal with here. Now I'm just going to keep on keeping on. So I'm going to complete the square. Square root half squared. So I just put in 100. But I didn't put in 100. I put in 100 times negative 3/4. So what I actually put in was negative 75. So to balance that out, I need a positive 75. And negative 79 plus 75 gives me 4. So there's my answer. Again, please, especially for this one, this is the hardest problem. Try to work through it on your own, hit pause, and when you think you've got it, push play again and see if you came up with the same answer. So I'm going to get going to it. I'm going to start by completing the square with just those first two terms. So I'm going to say y equals, but I need to pull that negative 5/8 out. So I know this here is going to be x squared, but what goes next to the x squared? If you're having trouble with that, just know that we're doing negative 15 over 4. We're dividing by negative 5/8, so that means multiply by the reciprocal. And first and foremost, a negative times a negative is a positive. 4 goes into 8 twice. 5 goes into 15 3 times. Oops, what just happened? Sorry about that. And 3 times 2 is 6. So that means the number that I'm going to put here is plus a 6x. Now I just finish it off. That means I will have y equals square root half squared. 3 squared is 9. But what I just put into my equation here was negative 5/8 times 9. So that means I've just put in negative 45/8. So that means to balance it out, I'm going to add 45/8. That leaves me negative 69/8 plus 45/8. That leaves me with a negative 24/8. And don't forget we have that negative 5/8 out in front here. And so to just simplify this, I'm going to have y equals negative 5/8 times x plus 3 squared minus 3. Just for giggles, because this just tickles me. I love it. It makes me so happy. I'm going to show you how to use completing the square to solve a problem like this. This is a quadratic. So just watch. One of the things I'm going to do to kind of make this easier, I'm going to get rid of this c automatically, just so I don't even have to think about it. I don't have to see it. So I have negative c. I have ax squared plus bx. And you know what? Since I'm actually solving an equation here, I'm again going to make my life a little bit easier. I'm going to get rid of this a. So I'm going to divide this whole thing through by a. So I will have negative c over a is equal to x squared plus b over a x. Now what we're trying to do here is to use completing the square to solve. So I'm going to complete the square. I'm going to complete the square on this half. The reason why I divided by the a, it just makes it easier. I don't have to deal with the fractions and stuff. So I have negative c over a equals square root half squared. But I just put into my equation here, I put in b squared over 4a squared, because I put in that guy squared. So you can either think about it as I put it in over here, so I need to take it out, or you can think about it as, hey, I put it in on this side, so I also need to put it in on this side. And then what I'm going to do is I want to get a common denominator. And so, oops, I need a squared here. My common denominator is going to be the 4a squared. So let's tack on a 4 a squared. So I'm going to tack on a 4 and an a here. Maybe this is starting to sound familiar to you. Now I've got b squared minus 4. I'm going to put it in alphabetical order. Come on. AC all over 4a squared is equal to x plus b over 2a. And this is solving by completing the square. So now I'm going to finish solving it. I'm going to take the square root of both sides. Don't forget, when you take the square root, you get plus or minus. So now I have plus or minus square root b squared minus 4ac all over. This stuff I didn't leave under it because I can take the square root of 4 as 2, and the square root of a squared is a. And then, maybe you see it, I love this, I end up with x is equal to, I'm going to subtract that, so negative b plus or minus square root b squared minus 4ac all over 2a. Now we have the quadratic formula. So it just so happens your quadratic formula comes from solving by completing the square. No, you're not going to have to do that. I just think it's cool and wanted to share it with you. All right, guys. So what we're going to be going over and talking about next time, which will be Wednesday at 10 o'clock, we're actually going to do, I'm changing what I had planned. We're going to be doing distance and midpoint, because distance and midpoint is more of a review. It's going back to geometry, but you absolutely need to have this idea of completing the square. You need distance and you need midpoint in order to do any of our conic sections. So that's what we'll be talking about. I hope to see you guys there.